Hello, everybody. My name is John Lewis, account executive with Tech B2B Marketing. Thanks for joining the Manufacturing Matters podcast, where we discuss topics related to manufacturing and automation. I'm speaking with Tim Stellmacher, Vice President, Sales and Development at PBC Linear. And we have a special guest, Jeff Johnson, who has over 15 years of ball screw experience in both design engineering and product management. Thanks for joining me, guys.
Thank you.
Today, we're going to be talking about PBC Linear's new mini ball screw product line, which they will be showing at the upcoming Automate show in Detroit. We'll also be going to try doing something a little bit different today and discuss some of the applications and some of the factors to consider when specifying a ball screw for your motion control application. And I hope it makes a really great video. So Tim, tell us a bit about the new mini ball screw product line.
Thanks, John. Yeah, the mini ball screw line is many years in development. After listening to our customers and getting feedback from the marketplace, we really started to hear that there was a need for a mini ball screw line that was high quality, made in the US, available from stock, and really something that we can bring to the market. The market feedback is that this was a need, so we are coming out with a 6, 8, and 10 millimeter diameter line of ball screws. As you said, we'll be at Automate. Automate is the 22nd through the 25th of this month. At that, we'll be in booth 1826. At that booth, we'll be displaying our Cobot feeder, which is a newer product, and then also releasing the mini ball screw line. You can come by the booth, grab a free sample, or you can contact me at tim.stellmacher at PBC Linear for a free sample at any time. Samples are available. And we're looking forward to getting these out into the market.
What are some of the applications that PBC Linear is targeting with the new mini ball screws?
Overall, we're looking at getting these into the medical, lab automation, semiconductor. These are some of the industries that we believe that are going to be hot after this. As far as automate, many of the robots that are doing much of the automation at this time could also use the mini ball screw line. So we're looking forward to getting feedback at the show.
So Jeff, I want to go over some of the key factors to consider when specifying mini ball screws or ball screws in general for these types of applications that Tim just mentioned. Is precision an important thing to consider when specifying a ball screw? And could you tell us a little bit about why?
Yeah, absolutely. And in the industry, there's kind of some confusion on terminology. We talk about accuracy and precision. A lot of times customers will speak of those as being interchangeable, and they're not. They're two separate terms that, as we define ball screws and how they're used in the application. So first we talk about accuracy, and that is defined by the screw itself. And that can be determined by how it was manufactured, whether it was rolled or ground. And it's accuracy. So when you think about a dartboard and you're trying to throw that dart toward the center and hit the bullseye, that's accuracy, trying to be right in the bullseye. Precision is slightly different. It's the repeatability. It's the how often do I hit the bullseye? What's my grouping? And that's when we talk about precision. So there's two different terms. Accuracy, that's how close the load or my application and movement is. And then it's repeatability, and that's more defined by the nut itself. And it's that repeatability. It's how frequent that I hit that point that I'm trying to target.
So it's precision is combines like both positioning a travel or positioning accuracy and repeatability, or together?
It's more in the repeatability, yes, for precision. So when we usually define again a ball screw, we talk about lead accuracy, as Tim mentioned, a 6 mm ball screw, you'll have a 6 mm diameter by 1 mm lead. And it's the lead accuracy. It's that if I turn the screw 1 revolution, did I actually travel that 1 mm, and how close to that 1 mm of theoretical travel did I go? That's my accuracy. Precision, again, is if I make that movement 10 times, did I hit that target all 10 times? So it's that grouping on the target or on that dartboard.
Okay, Jeff, thank you. I appreciate the clarification. Now, is orientation or the position or direction that the force is applied, whether maybe it's horizontal or vertical, is that a factor that should be considered when specifying a ball screw?
Oh, absolutely. And again, that's another one that customers tend to forget about. Ball screw wants to have the load axial. That's the way it's designed. If you have it horizontal, that's the simplest case. Usually there's profile rail, there's linear bearings, there's linear rail that are supporting the load, and the ball screw itself is doing the motion. So that load orientation is extremely critical. If you're going horizontal, it's simple. The load is always applied axially to the screw. That's the way the ball screw likes it. Once you turn that system vertical, now the load direction is one unidirectional. It's now completely down. So that has multiple effects on the design of the system itself. So it affects how the ball screw wears. It affects how you do your movements, both in speed and acceleration. And a lot of customers forget about that. A duty cycle or a cycle back and forth, you go up, you go down. And as you go down, the speed and your deceleration, that adds extra load to the system that a lot of times customers forget about. So now you've got almost an implied impact load at the bottom as the load transitions and reverses. So that reversing load is really critical on how you design and specify a system.
Great. Now you mentioned speed and acceleration there. Can you talk a little bit about why it's important to consider those factors when specifying ball screws?
Yeah, speed is very critical. So we talk about speed, and there's ball nut speed and there's screw speed, and you usually have to separate that. So if you look back at the back of a ball screw catalog or on a website, they'll talk about critical speeds. So the first critical speed is of the screw itself. So it's how fast you spin the screw. And think of the screw as either a long cylindrical item. If it's short, it's not as critical. If it gets longer, it becomes more of like a guitar string. And so that critical speed is the first harmonic of the screw, and you'll get vibration. And once you start getting vibration in the system, it leads to corrosion, it leads to reduced life, a lot of effects. So you try to control the speed, obviously. So customers will want to move the load as fast as they can, back and forth, get to their position as quickly as possible. But there is a limitation on the screw. And again, it's that first harmonic, the dampening of the system, the screw vibration. And we talk about that as critical speed. And that's defined by the load itself or the end supports of the screw. The second part of it is critical nut speed. That's how fast the nut can spin. And what limits that is the return system in the nut. It's how fast the bearings recirculate through the return system. And the miniature metric screws, these have an internal return, very smooth, very quiet, and that type of design lends itself to higher nut speeds. So again, ball screw design, how it was designed, how it's installed in the application really do limit you on how fast you can make a movement.
Mm-hmm. When you were talking about orientation, you also mentioned duty cycle. Can you talk a little bit about that factor and why it's important to consider?
Duty cycle unto itself is not overly critical. Usually lends itself more into a discussion on screw life, and that's what we tend to look at. It can get extremely complicated when you look at duty cycle and what we consider a move profile. Typically, it's just a trapezoidal looking movement where you have an acceleration, a ramp up, you've got a constant motion, and then you got a decel. All these are very critical in the movement. You can have multiple accelerations, decelerations, and load profiles, but the most typical is just that trapezoidal looking move profile. And acceleration is, again, one of those items that is typically forgotten about. If you try to find ball screw acceleration limitations, it's extremely challenging to find anything on acceleration. And we tend to try to limit that to 1.5 Gs. And that's more of a rule of thumb than an actual design limitation, because actual max speeds, actual acceleration, decelerations are really application based and need to be put in the application and defined there. So it does take some experimentation, some trial and error to get a defined move profile. But once you do get that, that lends itself now into the life of the screw. So we talk about that, and that's one of the great things about ball screws is it does have a defined life. And so if you're looking at ISO, DIN, or JIS, all these international standards define how we define life of a ball screw. And for metrics, it's usually a function of 1,000,000 revolutions. And that's our L10 life, or statistically, 90% of my ball screws are going to achieve this life. And in reality, they achieve much more than that life. So even if I rate my ball screw at, just pick a number like 100, more often than not, those ball screws are going to last to 200, 250. But statistically, over 90% are going to achieve just that minimum value. So we look at move profile, we look at duty cycle, and that's to achieve that end function of life.
What do engineers specifying ball screws need to understand about travel, or the distance or range of motion of a motion system when specifying ball screws?
Travel, especially a miniature, you've got a couple different factors. Most applications are going to be really short. So travel on a really short application has its own challenges. If I'm only moving 100 millimeters, that's not so bad for a 1 or 2 millimeter lead ball screw, because you're going to get 100 revolutions or 50 revolutions. And then ball nut and ball screw, they actually like that. That's actually not too bad. Where you get challenges is if the customer is looking for 1 millimeter travel, 2 millimeter travel, whereas the ball nut's not fully recirculating, it's only making 1 revolution. That's where it gets more challenging in how you define life, and where the design, the function of the return system play a critical factor on how that's going to perform. So some applications that I probably would throw out there, Tim mentioned medical. Let's talk about a fluid pump. Fluid pump travel, for the most part, is extremely short travel. You're looking at maybe 10 to 100 millimeters of travel, but really the last 1 millimeter travels where most of the force is being applied. And that's got issues when it comes to, trying to define ball screw life. So travel, when you get short, has issues, but travel when you get long has issues also. So let's look at like a 6 millimeter ball screw. Let's say you want to travel 1 meter. That's extremely long. That's your guitar string. So now you're looking at speeds. You're looking at the critical speeds of the screw itself, that travel, because you're going to get sag in the ball screw. So now your support rail system is now more critical. So when you get long or when you get short, it becomes critical. It's that kind of sweet spot in the middle, 100 to 200 millimeters, where these type of screws function the best.
Thanks, Jeff. Yeah, the last factor I'd like you to discuss a little bit is load, or the weight or mass applied to a motion system.
Yeah, another misunderstood area of ball screws. Ball screws are designed to be completely 100% loaded axially, and that's in the direction of the screw itself. If done correctly, the ball screw will last its L10 life. It's very predictable, operate correctly for many years or revolutions, depending on how you design your system. But again, it has to be axial. And when customers try to determine, what is good enough, it's probably not good enough. It really has to be critically axially defined. So it's that support structure. It's those linear bearings that really define how well the load is positioned and moved. So when I see ball screws returned after failure, a lot of times you're looking at deformation of the screw and nut, and that tends to be because the load wasn't properly aligned. So just to put it in perspective, if you've got a radial load or a moment load on a ball screw, that L10 life now drops over 90%. You lost 90% of your load by applying a radial or moment load to the screw itself. So you lose a lot of what you thought you had. So it's extremely critical. So when you look at design calculations or design sections of a catalog, and they say you need to be, parallel to the support structure within a half a thou, it's critical. It really does need to be that good.
Thanks, Jeff. That was really interesting and informative. I appreciate your time. Tim, you mentioned earlier, that PBC Linear will be at Automate booth 1826, but I wanted to give you a chance to remind folks here, for any of our viewers that may not be able to make it to Detroit, how else would you recommend that they get in touch with you?
Yeah, so you can contact us at, you can go to the website, which is pbclinear.com. We have availability there to take a look at the line and request a sample. You could also contact me directly, again, tim.stellmacher at pbclinear.com. You can, again, just get a hold of me. I'll get that free sample out to you. As you said, we'll be at Automate in booth 1826, and you can also grab a sample there. And I just wanted to thank you for having us today, John. This is a product line that we're very excited about. It's been a labor of love for many years between our owner, the engineering team. It's really something that PBC has been working on to get a great product. And so with those years of development, we've come up with something that we feel is different. It's precision. It's a small diameter ball screw that is customizable. We're able to get you samples from stock, and we're excited to get this product released.
Oh, you're very welcome, Tim. It's been a pleasure talking with both of you today. Thanks for joining us for Manufacturing Matters, everyone. Until the next episode, I hope you all have a great day.